Alright, so in this question we're going to look at modelling of quadratics, and this is really just an area where we're taking worded questions, creating a quadratic equation, quadratic equation, and solving it for whatever information we've been asked to solve. So we'll go through this first problem here with a highlighter and look at some of the key areas we need to understand before we start solving. Alright, so the first thing we need to know is key information. So she's asked to make a rectangular vegetable garden. She's got 20 metres of fencing wire, which she'll use to fence 3 sides, with an existing timber fence making the 4th side. So she only needs 3 sides. So we have to calculate the maximum area she can enclose. Alright, so there's a few things we need to do here. First of all, we need to know what the width and the area will be. We might do a quick sketch. So we have this existing timber fence here. We have then 3 sides. Now it says it has to be a rectangle, which means we know that 2 sides are going to be the same and 1 side is going to be different. All right, so we'll call this X and Y, and we'll say that the perimeter equals 2X plus Y. All right, now we already know that she had 20 meters, so 2X plus Y has to be 20. Like so. So there is one equation that we're working with here, and that's really just putting the information in the question into terms that we've drawn and interpreted. So then the next thing we want to do is to work out what the area of the garden might be. Now we know that area equals length times width. We know that instead of length and width, we're going to be using X and Y. So we can say that the area equals X times Y, like so. All right, the next step to do is to have a look at the equations we've written and to ask ourselves, what have we been asked to find? So we'll go back to the question and look at the last sentence where it tells us what to do. It says to calculate the maximum area. So this last equation we've written here, area equals, is the one we're going to be working with because this has area in it, which is what we've been asked to find. So let's put that to the side for now and go back to the perimeter equation and see if we can rearrange this. Now the reason I'm wanting to rearrange this is because if you look at the area equation, you can see that it has 2 variables. All right, we really have a situation here where there are 2 equations. So our logic tells us we must be dealing with a situation of simultaneous equations. So let's try and rearrange the perimeter equation until we can get one of the variables by itself. I'm going to choose to get y by itself because random reasons. So I'm just going to move the 2x to the left-hand side, like so. Now this equation here, I can actually substitute back in place of y in the area equation. It looks like this. So, undo that. X times 20 minus 2x, which we could expand out if we wanted to, but I'm going to leave it like this because as it is, it shows us the x-intercepts of the area equation. Alright, so I'm just going to solve that equation for what the x has to be to give us the area. So first solution is either that x equals 0, now I'm using the null factor law in case you hadn't worked it out, or x equals 10, which comes from solving this second bracket here. Now, what that means practically, let's just do a quick sketch of a few cases. So we'll go back to the initial drawing that we did, which was this river and a field. So if x equals 0, we're going to have 20 meters of wire that just runs along the river and has no width, which is pointless. If x equals 10, we're going to have 10 meters of wire straight out from the river, then 10 meters of wire directly back to the river, and nothing in the middle, which is also pointless. So now we come to doing a quick sketch of the graph because that's going to be our next helpful thing. We've got this. If x equals 0, there's a solution there, x equals 10. Now we need to find out what the maximum area is, and if you remember your quadratics, the maximum points to a turning point. So what's halfway between 0 and 10? Quite clearly that's 5, so we'll put the axis of symmetry here. And what that means to do next is that we need to plug in x equals 5 into the area equation. So we're going to have area equals 5 times 20 minus 2 times 5, which will simplify down to 5 times 20 minus 10. Sorry, missed a bracket there. 20 minus 10 is 10. Oops. And 5 times 10 equals 50. Now the units were in meters squared, so we have to write that in there. That means that the height of the turning point is all the way up here, and we can now fill in the rest of it, which is there. Now, the graph was not strictly necessary to the problem. However, it does sort of all tie back in together if we go back and look at the problem. So let's have a think. The original question says to calculate the maximum area she can enclose. Look at the quadratic we've drawn. It's a maximum. So this turning point here is the answer to the problem. We knew here that 50 meters squared was the turning point. So once we sketched it, we were able to see that that was the maximum area she could enclose. All right, so this 50 meters squared here was the actual answer to the problem. All right, so just to reiterate, the first step we did was to write down some of the information we'd been given after we drew this picture, because this picture was quite helpful. We substituted information that we'd been given from the problem into the formula, and we did that with the area also. The next step was to substitute the first equation into the second equation using simultaneous equations, then to simplify and solve from there. Then we had to think logically through the problem and ask ourselves, where would I find the maximum? Maximums indicate turning points, so therefore I need to find the turning point, which will be halfway between the two x-intercepts. Then last step is to substitute that the x value of the turning point into the equation to find out what the y value is going to be. We drew a graph just so we could see that the problem was linked to quadratics. All right, welcome to the next example in this model in quadratics, and it's one that I'm quite excited about. It's about projectile motion. It's about a cricket ball being thrown by a fielder. It leaves his hand at a height of 2 meters above the ground. Now, you might think to yourself, why is it 2 meters above the ground? But if you think of yourself throwing a ball, you don't throw the ball at ground height, you stand above it. All right, so then the wicketkeeper catches the ball 60 meters away at a height of 2 meters. All right, so when it says 60 meters away, that's horizontal distance on the x-axis. That is not, as you can see, it's not the path the ball follows. It is horizontal distance. All right, the question goes on to say, it is known that after the ball has gone 25 meters, it is 15 meters above the ground. All right, so that's this point here they've given you in the middle, 25, 15. The path of the cricket ball is a parabola, which we can see with an equation given in general form. So if you think back to the previous set, when we're given general form, we have to have 3 points that we can use. So let's start by identifying the 3 points. Point number 1 is the initial, and it is 0, 2. Point number 3 is the one given to you. Notice that it's not the turning point. The turning point seems to occur roughly just a bit after there. Another thing we can remember to understand why this is not the turning point. Where should the turning point be on the x value? It should be halfway between 0 and 60, which is not 25. So remember, this point here is not the turning point. All right, and the third point we're using from this graph is this last one here, which is 60 meters away and 2 meters above the ground. All right, so our 3 points are 0, 2, 25, 15, and 62. Now, if you remember how to use the general formula, you have to create 3 simultaneous equations. So equation 1 is using point number 1, and it's going to look like this. It's going to be 2 equals a times 0 squared plus b times 0 plus c. All right, I can simplify this straight away. 0 squared is just 0, and 0 times a is 0, b times 0 is 0, and c. So straight away I know that 2 equals c. Going back to the graph, we can pretty clearly see that the y-intercept of it is at 2. All right, equation 2, oops, not writing. Equation 2 is using the second point, which is 25, 15. So it's going to be 15 equals a times 25 squared plus b, didn't need a bracket there, b times 25 plus c. This one is slightly harder to simplify, so I'm just going to leave it as is for now, because we might find out that later on we didn't need to do this. And the third equation is using the third point, which is 60 and 2. So 2 equals a bracket 60 squared plus b bracket 60 plus c. All right, so now comes the maths. 25 squared is something big. It's 625. So I'll simplify equation 2 just next door. So 15 equals 625a plus 25b. Now at this point, I'm actually going to substitute 2 equals c in place of c, because it's not helpful anymore to leave it out, and I'll have to do that with both of them. I'm going to move this 15 across, so I have the null factor law. So 0 equals 625a plus 25b minus 13. And then I'll do equation 3 as well. 60 squared is 3,600. So 2 equals 3,600a plus 60b plus 2. Rearrange the 2 across to the other side like I did previously. 0 equals 3,600a plus 60b, and the 2 cancels out the c value because it became a negative. All right, so this is equation 3 and this is equation 2, just been simplified. I'm going to line them up to see what else I can do with them to solve them. So it's going to be 0 equals 625a plus 25b minus 13, and 0 equals 3,600a plus 60b. All right, I can't be bothered working that out by myself, so I'm going to use my calculator. I've prepared a little video here of me doing so, which you can see here. So we go to the main, click on that bracketed 2-entry line, type in both equations using 0 equals. Notice that I've used x and y instead of a and b. You didn't have to, it's just that x and y were on the keyboard on the main screen, so I don't have to use the ABC option to enter different letters. All that matters is I translate them back to what is needed at the end. So pausing there, I have my values for x and y, which are a and b. So we can see here that the calculator has told me that a equals negative 13 over 875 and b equals 156 over 175. Checking your values in the textbook, those are the right values. Now the final step for this part is to plug those a and b values back into the equation, which the original question told us wanted it in general form. So I have to go minus 13 over 875 times x squared plus b value of this times x plus the c value of 2. Now this is the equation of the parabola. All right, so we're have found out what it is. The A, B, and C values really don't tell us too much information, apart from the fact that the A value is a dilation and it's stretched it out a little bit, but 13 over 875 is quite a meaningless fraction when you're talking about parabolas, because no one can visualize that sort of thing. All right, so I've just realized I haven't put the questions in, so I'll just do that now for you so you can see what we're meant to be doing. We haven't done anything wrong, I just didn't put them in here. The first one says to find the A, B, and C values, which we've done. The second one says to find the maximum height of the ball, which we'll do now. So now, normally one thing you could do when you're given general form is to complete the square, but given those nasty fractions for a and b, I'm not going to go near that. So what I'm going to do is I'm going to find the axis of symmetry, which I already found, or I worked out originally, it's x equals 30. Then I'm going to substitute that in place of x in my equation. So here is the calculator doing that right now. You'll see it pop up on your screen. We'll just have a quick look at it. So I've just gone to the calculator, I've typed in y equals, I've used my a value with the fraction button, and I've used, instead of x squared, I've used 30 squared. The same with the b value and its x, and then the c value was just 2, so that was easy enough. We can just hit enter, and there is our maximum height for the ball. It occurs at 538 over 35 meters above the ground. So we could write that down because the calculator won't tell us the label, so it's y equals 538 over 35 meters when x equaled 30. Alright, so on to part number 3, which was to find the height of the ball when it is 5 meters horizontally before it hits the wicket keeper's gloves. Alright, so that, just to get your head around that, it says to find the height of the ball when it's 5 meters horizontally before it hits the wicket keeper's gloves. So here are the wicket keeper's gloves at 60. 5 meters horizontally before that would be at 55, and then it wants you to find the height when it's at 55 meters. All right, so we'll just type in something like this. Y equals, what do we have? Minus 13 over 875 times 55 squared plus 15, oops, move that out of the way, 156 over 175, 55 plus 2. And again, I'm not going to plug that into my brain because it hurts at the moment, so I'm just going to plug it into the calculator, and I'm going to find out that y equals 213 over, oops, not 55, 35 meters when x equals 55 meters. So these questions are really just applying what you know about quadratics and asking you to practically work with them. You can see how helpful it is to have a picture. In the previous example, I drew one first, or as we went along, and in this example, they've given you one first of all. But you can see that in each part, 1, 2, or 3, how we referred back to the picture and were able to use it to help us understand what was going on. So pictures are quite valuable in quadratics, all right? And I encourage you to do a quick sketch as you go along through each question.